Okay, there we are. We're on track. Uh, maybe I forgot. I will post. I forgot. I thought I put it in here. I will put in the practice test with the key in case you need to pull it up. You should still have yours, but we'll be okay there. Came up with a little bit of a calendar for the next 2 weeks. So, in looking ahead, chapter 3 gets us into something called probability, and that's chapter 3, 4, 5, 6. I thought it would be better to test you all on that one topic together, which means we'll need to take a real test after chapter 2. So we'll do chapter 1 and 2 together. So it does mean the test will be smaller. It's just over the 2 chapters. So what we're going to do is this week we're working to learn the material for chapter 2. What I did is I gave us some time as far as the review. I gave 2 days for a review. I think we'll only need one, but I scheduled out 2. We'll only need 1 day to take the test, but I blocked out 2 days just in case. So we have time to get ourselves prepared. But what I'd like our goal to be is by the end of this week, at least, to get through chapter 2 into that homework and ready to take another practice test on chapter 2. Over the weekend, notice on my schedules, I do include Saturday and Sunday. We don't have school, but you might need to do some work there, going through your notes, finishing up homeworks. So that's what the weekends are there for. And then Wednesday is just a work day. I'm not here, so we won't have anything new, but those, so that's why I'll weight it heavily on Monday and Tuesday. We'll do our instructional part so that there's something for you to do on Wednesday. Okay. And so we're going to start into chapter 2, descriptive statistics. I've got my slide deck here, and then there's also, again, those resources that have some videos that will take you through the notes as well. If you want to watch those, I'm recording this one. It'll be posted in there if you need to go back and review anything. Um, other than that, we're going to start today. So chapter 1 was primarily about vocabulary, right? We talked about what descriptive, that there was descriptive statistics, what went with descriptive statistics. There's another type. Does anyone remember those? Descriptive statistics were about a sample, and there were ones that pointed to the population. What did we call those? Inferential. Okay, so we'll start using those so you get familiar with them. Again, you might not necessarily need to pull them up, but when you see them, we'll know what it is. And we'll see how what we get today, we start looking at data and applying some of these vocabulary words we've been using on data. So we're going to look at frequency distributions and their graphs, and then we're going to look at more types of graphs as we go forward. So first of all, we're going to take a look at what a frequency distribution table is, and then we're going to look at some data and we're going to make it ourselves. Okay, but before we try to make it ourselves, what we will, my pin here, what we will do is we notice that in a frequency distribution table, the simplest one, there's something called a class. And so what this is saying is that whatever our data is, it's numerical, right? And that the data that contains 1, 2, 3, 4, and 5, whatever it is, how many pieces of data are 1, 2, 3, 4, or 5? 5 pieces of data. They could all be 5s, they could all be 1s, they could all be 3s. We don't know, but we know in that interval there are 5 pieces of data. Okay, so that's what a frequency tells us, is how many pieces of data are in each of these classes. How about the class from 21 to 25? How many pieces of data are in that? 5. So it's nice. And what we're going to look at is just if you see raw data, it's hard to tell anything, but this is going to organize it for us so we can start seeing patterns in the data. Like what happens the most? Well, this has 8 and that has 8. So those two intervals have the most, so you could kind of spot those kind of things. So in a frequency distribution, we have the frequency, which means how often something occurs. We'll do that by counting. And then there's also a class, and a class size, and we're going to see how to do all of that. Okay, so there's a lower class limit. Each class has a lower limit. In this case, 1, 6, 11, 16. So that's the lowest that data could be in that class. There's also an upper class limit. So we go from 1 to 5. Additionally, there is a class width. Notice they're all the same width. So 1 to 5 is 1, 2, 3, 4, 5 pieces of data. Or you could take the first class lower limit minus the second class lower limit, 6 minus 1, and you see that that's got a width of 5. Each class has the same width. And that's, again, what we do this so that when we look at this data, it makes it sort of standardized, and we're able to start to make some inferences about the data. Okay, now how do we make that happen? Again, we're going to show you technology that will do this. You input the data and it will make a frequency table for you. It'll make all the charts we're talking about. What we want to do today is let you know how to sort of do it so that it's not just magic. I put in the numbers and it gives me what I want, right? We want you to see what the computer's doing. Okay, so thinking about that chart we just looked at, it was for some different data. But for this data, what do we have? We've got cell phone screen times and in minutes for 30 US adults. So if we counted that, we should see there's 30 pieces of data. There's 3 rows, 10 in each. So there's 30 pieces of data here. And we're asked to construct a frequency distribution with 7 classes. Okay, that last one, each one of those classes. So that's what we're going to do. What do you think? Let's just get started. We've got step by step it'll give us, but where do you think we start? What would be good to know about this data when we want to say what should, making this frequency table? There's 2 numbers that would be really important to know. Which are those 2 numbers? Smallest and the biggest. Good. Kind of natural. So we got to look for the smallest. And I first thought 165, but so it's easy to miss it. You've got to make sure you've got the smallest. Look at them all. What about the biggest? I see a 400. Oh, but there's a 405. Anyone see anyone bigger? Okay. So notice a lot of this stuff is kind of tedious, and it's prone to error, but you just got to be focused, and we've got that. So we've got our largest and our smallest. What do you think we should do next? How about something called the range? How do you think we would find the range of our data with those 2 numbers? Subtract, take the biggest minus the smallest, and that tells us how much space is between them. Good. So see, a lot of this statistic stuff is very intuitive, right? So we're going to take our 405 and we're going to subtract 155. And what do we get there? Calculators. 200 and 250. And if it looks like I'm real smart in calculating these, it's just the 3rd time I've taught this morning, so I remembered the numbers, so I'm not actually doing it. What would we do with that 250? Because that's the smallest to the largest. We want to divide it in how many classes? So what should we do? Divide it by 7. Does that make sense? You want to divide it in 7 classes, you take that number and divide by 7. And when we do that, what do we get? It's not the midpoint. It's the difference between the smallest to the largest. So it's kind of how wide it is. We'll get to that midpoint though. That's a 35.7. Now, should we use that for our width? Wouldn't that make calculations? No, we should. We should round up. And actually, we always go to the, actually think of it as going to the next one. Even if it was 35.1, we'd still go to 36 because we've got to include everything in there. So we've got to be big enough. It's not just rounding because we never round down. We always go up. Just put it that way. So our class width is going to be 36. And so we've got everything here to actually start it. What do you think we should make the lower limit of the first class? It's okay to be wrong. It's also key. Lower limit of the first class. Well, we got to make sure that we don't leave anything behind. So is there anything smaller than 155? So if we started there, we'd be okay. Start at the bottom and work up. Right? So we're going to take 155 as our bottom of our class. Okay? Okay. I've had that happen before when I'm teaching. It's terrible. Okay. Now we want it to have a width of 36, right? So how can we do that? If you're looking at the other one, right? If we add 36 to 155, we get 191. So that will be that'll be the lower limit of the second class. And we could keep doing that. How would we get the upper limit of the first class though? Can't overlap. We subtract 1 from this lower limit, we will get 190. And again, we'll walk through, there's sort of printed instructions that do this step by step, but I just want you to see it. Doesn't that kind of make sense? And then if you were to count on your fingers from 155 all the way to 190, you would see you get exactly 36 numbers. Okay. And again, we would add 36 to 191, and you'll get 6 and 1 are 7, 3 and 9 are 12, carry the 2. So that's 227. So this will be 226, okay, because you subtract 1. So we could then just go ahead and start listing all our classes. And I'll start through the instruction. Any questions yet? Okay. Now in your notes, there's like some open tables, but they give you some different data. They also use this one a little bit later. We'll get there. So here's the deal. If they don't tell you how many classes, you want to usually use between 5 and 20. Less than 5, it's like there's not enough and it's not really valuable. More than 20, there's too much. So, and that's one of the homework questions. They'll ask you how many should you have. 5 to 20 is something you want to kind of remember just as a general rule. Look at this. They said, how do you find the class width? What did we do? We found the largest and smallest and subtracted it. You kind of knew that. That was intuitively, that's what you did. How do we figure out how many classes, how the class width? Well, you divide the range by the number of classes. So that's what we did. We took the range divided by 7. Felt pretty intuitive, right? And then also we got that decimal and we kind of said, well, let's just round it up to make the math easier. Yeah, round it up to the next level. So that's where we got the 36 instead of using 35.7. Okay, make sense? So those instructions are here. The next step is finding the class width, right? We were given the 7, so you divide, we got the 36. Finding the class limits, we just went through that. You start with the minimum data, so the smallest piece, we did that with 155. You add the class width to the lower limit, so we took 155 plus 36, we got to 191. And then we would subtract 1 from the lower limit of the second one to get the upper limit of the first one. So I don't know, for me, it just looks like lots of words there, but it was all intuitive. What we were doing all of this on the page before. So it was kind of natural as we went through it. Okay. And then find the remaining upper class limits. Okay. So if you did that, again, here's another sort of more graphical look at it. So we took the 155, we added 36, and we got the 191. And so that's there. And then you could see in the next slide, you could just keep doing that, find all the lower limits. And then to get the upper limits, what do? Well, you subtract 1 from the lower limit of the next class, and that gives you the upper limit of the previous class, right? So 199 minus, or 191 minus 1 is 90. 227 minus 1 is 226. So we're making our table. Okay. Questions so far? Doing okay? And again, we're either adding, subtracting, multiplying, or dividing, but it's just doing it all in the right way. Okay. And then what you could also do is on the upper limit, you'll see if you add the 36, that's going to give you your class width and the limits as well. Now, this is the part where we do tallies. And again, there's multiple ways. One way I do. So we want to figure out how many are in the class from 155 to 190. One way is you could go through here. Oh, 155, that's in that class. So I put a tally. And I keep, 165, that's in that group, right? It's between 155 and 190. And we keep looking. None of these numbers, these are too big. Too big. Oh, there's 168. And that looks like the last one, 195 is too big. So it's got 3 tallies. That's what they did. And they could figure there was a frequency of 3. And you could go to the next class and figure out how many, and it's just counting how many are in that group. Easy to mess it up, right? You miss one or you put one extra. It's tedious, but it needs to be done. Can you think of another way you could do the same thing, figuring out how many frequencies are in each of these? Could you start with 200? Say, well, where does 200 go? Oh, it goes here. So let me put a tally there. 239, where does that go? Well, it goes in this group. We could put a tally there. 155. So you could also do it this way, and that might be easier. You might not miss something. I think I have to start trying this way because I've done it the other way, and I always make mistakes. And yeah, Mrs. Lee came up. Yeah, she mentioned it last class, and I said, "Dang, where were you when I was learning this stuff?" I think that's an easier way to do it. So anyway, what we need to do is just figure out how many pieces of data are in each class, right? And so that's, again, it's not magic. It's just going through and tediously going through and counting how many, and then we've got our frequencies. The frequency should always add up to the sample size. So we were told that it was 30 at the beginning. When we do our frequency chart, we should have 30 at the end, a total of 30. So there's a check for us. And again, when I make a mistake, usually I'll end up with 29 or I'll end up with 31. And then I got to go back and try to figure out where I left one off or put an extra one in. And sometimes that's hard. You just have to start over. But yeah, maybe this going from the data to the tallies, that might work for you. Okay. I think we just have one, maybe 2 homeworks where you do that. Okay. Someone was mentioning about the midpoint. And notice this is similar to the range, but it's different. We don't subtract, we add. So for each class, what another kind of measurement we can use is we can take the lower class limit plus the upper class limit, divide by 2, and that gets us halfway between them. So if you took 155 plus 190 and divided it by 2, you'll get 170 something. Somebody got a calculator? $172.5. Okay. And what we can do with this is we can use that midpoint to represent that class now. So sometimes we'll do that because we don't know how many are at the low end, how many at the high end. So it's a way of thinking, well, let's just say they're all in the middle. Okay. So we could do that with each of the classes. Another column we're going to add to our table. Again, we've got our class width, we've got our frequency. We also have our midpoint now for each of them. And again, we'll see a table that does it. The other thing that's sometimes very helpful is relative frequency. Relative frequency. What is that? When you hear the word relative in math, what kind of number is that? It's a percentage, exactly. So just when you start hearing relative, so relative frequency is just the percent. And so you're going to take the frequency of the class divided by all of the total, which was 30. So for the first class, that is 3, frequency of 3 divided by 30. And that's going to be 0.1, which is 10%. Okay. Why is this number important? Because as we talk about a percentage, we can now use this chart for another sample of a different size, and we could even use it to apply to a population, right? We say this is what our sample was. Maybe that means 10% of our population, everybody there. So that's how we get to relative inferential statistics. Relative frequency gets us to inferential statistics. So that's our sort of our bridge there. So it's not all that magic, but it's turn things to percentages and we can talk about it. Okay. So the last one we're going to put in here is, and I have a hard time saying this word, cumulative frequencies. So it's a running total. So we're going to just kind of add them so that if we get to any place, we can say, well, there's that many up to this point. So what does it mean? Let's go ahead and look at this. So this doesn't have all of them, but so for each class, here's its frequencies. Notice they found the midpoint. We did the first one, 172.5. Here's another midpoint for each of the classes. They got the relative frequency, so they took the number, the 3, divided by, all of these are getting divided by 30 because there's 30 pieces of data, right? There's 30 in the sample. So we get all our relative frequencies. And then for the cumulative frequency, first one had 3, so you just have 3. The next one, you take the 3 plus 2, so we could say 5. And what it does is it allows us to say that there's 5 pieces of data below 226. If we want to jump down here to 298, we can say that there's 16 data points that are below that. So it's an easy way to do that. And we'll see later on we call this a percentile, a score that what percent are below a particular score. So it's a very important statistic thing. So if we have all these columns, we'll have everything we need to create the graphs we want to create. And so this is sort of like a pretty complete frequency distribution table. Okay, it's got its class widths, it's got its frequency, it's got the midpoints, it's got the relative frequency, and it's got the cumulative frequency. And what we're going to do now is see with just this table, we can make several different types of graphs depending upon what we want to do. Okay, so that's sort of the starting point. Once you get that, we can then produce multiple graphs and go from there. Okay, first graph we're going to talk about is called a histogram. What else does it look like? Maybe a bar chart. They're a little bit different. Bar graphs don't have to touch, histograms have to touch each other. Okay, so we'll see how that does it. So it's a bar graph that represents the frequency distribution. So you'll see the y-axis is your frequency, how many times it happened, and your x-axis are your data values. And the bars must touch. Now, think about our chart. One class ends at 190, the next one starts at 191. Are those touching? There's a space between them. So we got to do something. If we're going to do a histogram, we're going to do something to fix that. And it's not too hard. Consecutive bars must touch the numbers that separate classes. So we've got to come up with those sort of boundary limits where they're not going to touch each other. And one way to do it is you subtract half, because that's the distance, right? They're one apart. So to the lower class limit, you subtract 1. To the upper class limit, you add 1. Or sorry, you subtract 0.5. To the upper class limit, you add 0.5. So 190 plus 0.5 gives us the 190.5. 155 minus 0.5 gives us 154.5. And because our data is all integer values, there won't be anything on a boundary, so we don't have to worry about that. It's still contained, but now they're touching, right? 190.5 to 190.5. 226.5 to 226. So the boundaries are touching each other, okay? So there's a class limits. So these we call the class limits here. And these are class boundaries. Similar, but a little different, right? The class boundaries will touch each other. The class limits won't. That's in the homework, so just, okay? And there on the slides, so lower limit, we subtract 0.5, upper limit, we add 0.5, and then everything's touching. And now we're ready to make some beautiful graphs. I don't know if they're beautiful or not, but they're nice. Okay, so from this table, we can make a histogram. There's 2 ways we could do this. These are really both the same, but they're different a little bit. One way is we can use the class boundaries as the labels down here, and maybe that has a little bit more accuracy. It tells you that the data, that these 3 data pieces are somewhere between 154.5 and 190.5. That's all we know. We don't know they're all at the lower end or the upper end, but we know that there's 3 in between there, okay? Similarly, we could have represented this with the midpoints, because sometimes we just want to say, let's just represent it as sort of the average, right? 172.5. It's not, then we can represent everything with just 1 point. It just depends on what's being asked for. Both are accurate, both are correct. It just, do they want a midpoint graph or do they want one with class boundaries? Okay, but you can see the y, or how high they are, is based on the frequency, just right off the chart. All make sense? Okay. Good. So the reason we do this is, instead of looking at a bunch of data that's all are just numbers, right? That whole block of 30 numbers, can you tell? If someone asked you how many are more than 262, you could come, here's 262. So there's kind of a line there. All of these are more than 262. And you could easily say, well, oh, there's 7 plus 7 is 14 plus 6 is 20. There's 20 pieces of data that are bigger than 262 out of 30. So that's 2/3, right? You could also say, well, how much is spinning below 262? Well, you could see there's 5 plus 5, that's 10 out of 30. So about 1/3 are below that. And if you were just looking at the data, how could you ever pick that? I don't know. I couldn't. But see, when we get it to here, we can visually start making those. And you could do it with any number, but now you can start analyzing, looking for patterns. You can say, oh, this 298 to 334, that's the one that has the most, and then it drops after that. So maybe maybe you want to examine something, you know, what percent are below that, what percent are above that, all sorts of, it gives you a picture that you can now start determining what you want to go with this, what you want to do with your data. Okay. Another way to take that same chart, that same frequency chart, and make a different type of graph for a different reason is something called a frequency polygon. Now, what we do here is each of these points that come from the midpoint and the frequency. So this is, we don't use the class boundaries now, we're going to use the midpoint, and then we plot those, right? So we're going to, the x-axis will be the midpoints, and then we could use either the frequency or the relative frequency, but we'll see, I think this first one uses the frequency, and then we connect them with lines that help us see if there's a pattern, as you know, and you can kind of see this emphasizes not just the amounts, but sort of pattern that, you know, there was a 3 here, then there's only 2 here, and then it goes up, up, up until 316. Again, just focusing on the midpoint, and then it starts dropping off. Notice these polygons, they plot points that that are not on our chart, so they take that width and they give what's above and below. So we didn't have anything at 136, right? 155 was a lower, but they will plot those as on the zeros. Just how they do it. So this one just kind of helps spot trends. I think it might be helpful or it might not, but there's a lot of times when you're doing statistics, you take your data, put it into a package, and it gives you it'll give you a histogram, it'll give you one of these charts, and you just look at them, and sometimes you start to spot things, and you get some ideas about what this data means. Okay. Okay, time in minutes. We'll show you how to use some technology a little bit later, but right now we're just wanting you to kind of do it hands-on so that you know that you don't think of it as just magic, you put it in and you get it out, right? We want you to see what the computer's doing, so we have you do a little bit of that. We could, as easily done, there's another type of histogram, and it looks very similar. This, we could have used the relative frequencies instead of the actual frequencies. So instead of a frequency of 3, we could have used 10%, right? And the only thing that really changes when we do that is the scale over here. Notice that the frequencies are now relative frequencies. So these are percentages rather than numbers, not 3, you know. So again, this is now getting us a chart where we can do inferential statistics. We could apply this to the population, say, well, this may be what the population looks like. And we can do that as long as our sample was representative. So that gets us back to the stuff we were doing last week. So, and what you see, the cool part is, if you put them side by side, again, you can now say 20% instead of how many, right? But if you put them side by side, the graphs really look about the same, right? They have the same shape. The heights are about the same. It's just what's different is it's either an actual number for the frequency or it's a percentage, right? 10%. And again, with the relative, we can then apply it to other groups, other samples, or to a population. So that's where it's helpful. Notice for your notes, we're not doing the stuff for 21, 22, and then the first half of 23. And that's because those techniques, I've taught them before, the stem and leaf and some of these others, those are nice, like by hand techniques you can use. But once we start using technology, we don't need those. There's better techniques to do it. Okay, so you can look over them if you want. I've taken the homework problems on those out. So we won't be doing those types of charts. Okay. 46. We got just the right amount of time. So now we're going to focus on, so leave the frequency tables behind. We kind of done everything with frequency tables. But now we're going to look at some ways to graph qualitative data. Okay. How many of you have seen or heard of a pie chart or a circle graph? Same thing, right? So you see them all the time. What how much is in a circle? What does a circle represent? 360 degrees, so that's going to be important. We'll take that with us. And how much of the data? It's what? The data. How much of the data is in the circle? All of it, right? 100%. So the circle, the complete circle represents 100%. So we start seeing these relative frequencies come in. These segments, pieces of the pie, are a proportion of those, but they should all add, they need to all add up to 100% or 360 degrees, depending upon, we'll use those numbers interchangeably. Okay, so let's take a look at how we might draw one. And again, using certain software like Microsoft Excel, other technology, you put in the data and tell it you want a circle chart, it will do it for you. But what we want you to see is what is it doing. It's not too technical. Okay, so here's our data. Our data is qualitative, right? It's categories. People who got an associate's degree, a bachelor's degree, master's degree, a doctoral degree. These numbers are in thousands, so this is actually, you'd add 3 more zeros on the end to get the total number. So that's like 1,037,000 associate's degrees, 2 million bachelor's degrees, and so forth. So we want to figure out what part of the pie each of these is. So we need to know percentage-wise, right? So to find the percentage, what do we need first? We need to know a total so we can divide each of them by that total, right? So could someone help me? What's the total number of degrees represented here? See, it's going to be 4,000 and something. $4,072. Good. So the way we get each slice of the pie is we take its frequency. These are really frequency charts, right? And we divide it by the total. So we're just getting a relative frequency. So notice how we emphasize that. It's about 25%, but it's exactly. So notice I got this one. And so I'm going to get the percent for associate degrees. And 137 divided by 472. 255. You round it. And then, but to be able to draw it, that means about a quarter of the circle, about 25% of the circle. Or you could take 360 degrees times 0.255, and you get 91 point something. Maybe 0.6. It'll be on the next slide. So a quarter of a circle is about a 90-degree angle, right? So we could start drawing this. Okay, about there. There's my associate degrees. Bachelor's degrees is 2,000. You could say, well, that's about twice as much. So that's probably about 880 degrees. So here's our bachelor's degrees. And then the master's and doctoral degrees will split it up. And again, you could do the calculations to get it exactly. And that's what they did on the next slide. 91.8. So they've got these exact down to the 10th of a degree. And then you can use a protractor if you want and make it as exact as you need. Or again, your software program will do it for you. But again, it gives us a quick way to say, well, bachelor's degrees, that's about half. You just see it from, you didn't even have to look at the numbers. You can see it's taking half the circle. So maybe you say, we need to put more money because that's where most of the degrees are or something. This is where marketing folks come in and then they say, whatever you're trying to sell or wanting to do, pie charts can oftentimes be very powerful ways because they give people just an emotional appeal as well, right? Heck, you didn't even have to put these numbers in here. You could tell that easily. Or you can say, well, doctoral degrees, we're not getting many of those. That's a small slice. We need more doctors. So you better put some money there, whatever you want to say. But now we've got some means to make our case for whatever we're doing. So far, so good? Okay. We're going to get farther than we did in the other class. You guys are not comparison. It's probably me because, right, this is the third time I'm getting better. I learn as I go. So, okay. A Pareto chart. Now, this is similar to the pie chart in sort of that the height represents the frequency, and it could be a relative frequency. That's what we were plotting there. The categories are just listed across the bottom. And what we always do with this particular chart, a Pareto chart, is you list them from the largest to the smallest. So they will always be going downhill. It's made, whatever category has the most, it goes first to the left, and then you do it as you go through. Okay. So here's one with the top 5 causes of death in the U.S. Not necessarily a pleasant thing to talk about, but we can see heart disease is the highest cause of death, 659,000. So that's listed first, and it's got its frequency here. So remember, this is not a histogram. They're not touching. They're separated, and they are just representing categories. But notice they arrange them from the highest to the smallest as far as frequency. So that's just a characteristic of the Pareto chart. I don't know. The way I remember it is it sort of looks like parent. So the parents are big, so that's why you put the big one first. I don't know. Make up things that help you remember things. Make sense? So again, you're seeing the same techniques mathematically. We get that relative frequency, and we could do it. And again, we could make these to be relative frequencies, or we could make them the actual amounts. We're going to deal with this type of a graph much more later on. In fact, there's a whole statistics on it. This is what's called a scatter plot. And for a scatter plot, each item that we're discussing has to have 2 different measurements, 2 pieces of data associated with the same item. And then what you do is you graph on the x-axis, you graph one of those measurements. On the y-axis, you graph the other. And you could do it pretty interchangeably. The example we're going to look at is a botanist was studying lilies, and they were wondering on the different size if the lilies, the petal length if it got longer, was the width also wider. So they wanted to see if there's a relationship between the length of a lily petal and the width. So they measured a bunch of them, and then they would plot them something like this. So notice the petal length is here on the x-axis, so they measured each one, and the petal width is listed over here. So each dot, say this dot, I could say is a flower that had a length of, the petal was about 30 millimeters, and it was about maybe 12 millimeters wide. So that was one item, one dot. But what we use this for is to see patterns. Do you see that what happens as the petal length gets bigger? So I go this way, what's happening to the width in general? It's kind of also getting wider, right? So there seems to be this relationship. This is called regression. We're going to do a lot we'll spend a whole chapter on this. But what we want you to know for this one, what is a scatter plot? There had to be 2 measurements for each piece of data, and we plot one against the other and see if there's a relationship. As one gets bigger, does the other get bigger or not? So, and again, it's not really following a line. Some are different than others, but the general pattern, right? This helps us see a pattern. And one last one. I think this is the last one. We'll see. A time series chart where we have measurements that go over time. So maybe a plant growing, each month we measure it or something. Or in this case, they give us some data about burglaries and robberies over time. So year 2009 to 2019. We can plot this. On the x-axis goes the year. And on the y-axis goes the number of burglaries. We connect it with the line, and what do we see? What could you tell me about burglaries? They're going down. So maybe something's helping out. Again, you could kind of see it here in the numbers, but it just shows it there as it goes. And then you can omit the notes from pages 26 to 26. I guess just 26 would have done, but okay. So tomorrow we'll start in on the homework to kind of together, get us a little bit started, and then we'll maybe start into the last section as well. But yes. That's looking good. Yeah. So you actually did the one. Yeah, perfect. Nice. I like the color coding too.